Hello, my name is Miklos Fodor, and I'm presenting the rapid random restructuring paradigm. And in this chapter, I would like to speak about how a system's structure has its effect on what the system delivers as output. If somebody's familiar with neural networks, then knows exactly that the way how neurons are connected specifies exactly what a neural net is performing, what transformation it does. Just for remembering the general idea of how a living system we have visualized. This is the living system, which has its inputs, and as in a previous chapter I mentioned, it's very rare to have only one input. There is a transformation, and we are now very interested to see how this transformation happens and delivers some outputs. These outputs typically are used by another system, and they are using it as input, maybe with outputs of other systems, like this. In a previous chapter, I mentioned also the connections and the importance of how systems are connected. Living systems are able to perform these transformations or operations within this the boundaries of the system, and as we see also from this picture, all living systems are built from subsystems. So now the rectangle I was drawing shows a super system that contains these systems, and these systems are connected in a specific pattern. We see that 2 goes to this one goes to this one, and this one receives information from this one. Maybe this receives. Just to prove that it's this is a viable concept, let me show you some examples taken from my experiments, where my aim was to train a computer modeled, let's call neural network, but it's not a neural network because it's basically they are models of living systems. I was trying to teach these systems a pattern recognition operation, and the result of this pattern recognition I'm trying to show you the next picture. Here we see that there are 5 inputs, and this is the system. Sorry, the system is smaller. Is this way, and this system has 5 inputs. You can see with numbers 1, 2, etc. And and has one output, this number 11. The pattern what I wanted that this system should recognize was that we have 5 dots, and if 5 neighboring dots or 3 dots out of these 5 are all getting a true information, then the output of this number 11 should be also true. In all other cases, it should be false. So, for example, this one, and this one, then number 11 is true. If this one, and this one is true, then number 11 is false. A similar pattern recognition experiment, somehow differently visualized. In these cases, as we can see, the system itself is this one, and the inputs are coming from here. I used a different visualization just to make more understandable how very complex connection network appears within a system. Maybe that's why when we are looking a real neural network, then we can't really see what that network is performing, because this pattern recognition task what I modeled is very simple, even though the solution of it's rather unusual and seems to be chaotic for human eyes. Here the pattern recognition task was to out of 5 say lights, if 2 neighboring are light on, then this number 11 should fire or should produce a true answer or true response. The importance of this in the understanding of the structure is that if I change any of these lines, maybe I try to make it disappear. Maybe it's not okay. Let's see here. Okay. So if I delete this line, then the whole system crashes. It will deliver even either a lower quality result, so less accurate result, or it won't deliver result at all. So the structure defines one-on-one what is the system performing. Just to underline what I was trying to say here is that the structure, how the systems are composed, defines what an operation that system will perform. And here I have to make you remember the nestedness of this living systems, what we have discussed in the chapter of nested hierarchies, that within this system there are also systems, and if let's see like this, and these are also connected the same way as we see it here. No, not exactly the same way, but in a similar manner. And here again, if something something is destroyed, then the whole output of this living system will be totally different from what was previously. So all the small changes are important, or all the small links within the system. So there is no the leveling of the hierarchy is not important, meaning that on a lower level, if there's a trouble, then the whole unit will whole unit's output will be affected. And yes, you might say that here is a hierarchy, a pyramid, and here is the lowest level, and here is the highest level. And you might say that if here changes something, then it won't go fully evoke the system's performance. If the system's original performance, say you can never reach, or almost never reach 100%, but let's say, so 100% it's impossible. So only in a few in a case of few systems where you can approach and say 99.9% accuracy, or in case of modeling. But as the universe cannot be perceived one by one, then the outputs won't model the original object in 100%. So, but my original aim was to say that if we have reached a good enough solution, and this solution is delivering say 95% solution, then yes, you might be true that if here is a change here on this level, then this 95 will decrease only a few points, say to 94. If the change is on a higher level, then it might drop to say 20%. So the structure and the nestedness are connected this way, and in further chapters we will see how the opposite direction effects can be produced, meaning that from 95 we have decreased to 94 or to 20, and that's getting worse and worse. But let's see how changes improves in a positive way, and from a bad performance from a 20 it goes to 94 or to 95, due to also to changes in the links of intersystem links. Just in advance a sentence, maybe one link that was not existing can change the accuracy from 20 to 50. It's obvious, because when I was deleting one here, then I dropped it to 95 to 20, so if I make it back, then it can count from 20 to 95 again. Okay, thank you.